Hello musicians, welcome back. My name is Bucky Dirtle and I'm doing another video tutorial on the VCV Rack open source modular synthesis DAW, digital audio workstation. Now this tutorial is going to be about a module called specific value. And this is by Alikins right here. This is an open source utility that is very, very useful. You're going to find this one useful because it's going to help you identify what volts and frequencies and specify exactly what note you're getting right to the cent. It's a great little utility. It's kind of complicated because there's no documentation for this utility. And actually this is what we do here at utopian.io is we try to provide some guidance to users on how to use some of these complicated open source projects, and this specific value is an example of that because there is no documentation that I can find on this module. And there will be a little bit of gray area in here as well because there is no documentation. And we've also found a little bug that we're going to talk about as well. So let's just get to it. Now, first of all, specific value. Before I do, let's talk about what I have running here. You can see I have my audio interface right here. And again, I'm running version VCV Rack version 0.6.0, which looks a little different than the earlier versions, so you may see some different things here. Also, as of yesterday, our mixer is updated. This is the Fundamentals mixer. So it's named a little different and it looks a little different. One of the things I would have preferred with this mixer is in Rack, if I go to my LFO here, if I right click on a dial, it takes it back to the initial starting point, which for this LFO is top dead center. You can see right there, top dead center. I just clicked, it went there. The mixer levels, it used to be that these levels here, which were dials before, now it's sliders, their initial was 0. So I could easily go to a dial, hit right click, and it would instantly take my volume down to 0. That was really useful. I would like to see that. I would like to see that back because now the initial starting point is 100%, and oftentimes you have to take the sound down instantly because things get out of control. And now we have to take it and slide it down, so it's a little bit of a pain. Anyway, that's a little aside. Okay, specific value we have right here. I've got it connected to my VCO1, which is Fundamentals. I also have LFO, which I'll show you in a second. I have my scope right here from Fundamentals, and I have Bog Audio's analyzer, which is a frequency analyzer. So we can see what we're doing down here. And you'll notice I love my scopes. Great to see and hear what's going on in our sounds. Okay, let's talk about specific value. If I turn up my volume a little bit here now, you'll hear that we have a tone. I have a sine wave from my VCO, which is going, let me just show you this. My sine wave, my VCO, is actually coming out of the out here, going into my voltage per octave on this VCO, and it's going out of that into my mixer. I also have a line going out and into my well, now it's going into both scopes. I have scope and analyzer. Actually, I'm going to do something here now that this is probably a pretty good time to show you something like this. This is a little utility thing. The computer I'm running on here now is my road computer. It's a laptop that I take on the road, so it's not my fastest machine. So I'm going to up my the block size here to 2048 or 46.4 milliseconds. I'm going to click that. That's going to give me a little bit bigger buffer because I'm hearing the sound is kind of breaking a little bit because my computer is taxed a little bit. So that's a little thing you may want to do. And we'll probably find little or no distortions now because of that. So that's a little thing that you might want to know. Again, I did it here in my audio interface. The default I think was 128. I upped it to 2048. Normally on my main laptop, which I'm not using right now, I would on 1024. It seems to do the trick for me, but you know, every system is a little different, so you may want to play with that. Okay, specific value over to here. So what's happening now, if I turn my volume up a little bit, what's happening right now is specific value is controlling the frequency. Now if I change this main dial here at the bottom, you'll see it's changing the frequency of my oscillator. So it's controlling what the oscillator is doing because, as we've seen before in other tutorials, when we go out of a device like this and into voltage per octave, it will control the frequency that the VCO is producing. So we are controlling our frequency range by adjusting this knob here. Now you'll see there's lots of values changing on the screen here. I'm going to go over those for you. Before I do, let's just turn the volume up a little bit again, and I'm going to go in from my LFO. And you can see that my LFO is, I'm going to turn this down. So you can see my LFO is now controlling the frequency that specific value is putting out. So it's voltage control, and I got that turned down pretty low. So there you go, but we don't need to really hear that, so I'm going to turn that down again. And I'm going to disconnect that. I only wanted to show you that, just to show you that the in is where our voltage control goes in to control that specific value. So just to clear things up, I'm going to delete that LFO now. So I'll just move my oscillator over. We're not going to use it anymore for this tutorial, so I'm going to delete it just to get clear of it so we have a nice clean interface. Okay, so now I'm going to go back to the starting point here. I just right-clicked on the dial here, so it takes us back to the first starting point, which is, which you can see here, 0 volts, 261 hertz, You can see what's there. Now, let's have a look at what this does. Specific value, it tells us what voltage and hertz that the device, the module, is putting out, and also the control voltage that's going in as well, and as we just saw with the LFO. This can be really useful because there are times when we want a specific note, we want a specific hertz frequency, specific frequency. Right now it's at 261.626, and that will give us this frequency. We may want to produce an A440 for tuning. So if I go in here and click into my hertz, and I'm going to go Command A or Control A if you're on Windows, and I'll type in 440 return or enter, and that gives me an A for tuning. So that's an A. I'm going to turn this down again. And it tells me that when I type in that hertz of 440 hertz, or cycles per second, then that is actually 0.75 volts. 0.75 volts will give me 440 hertz. So if you're working in volts, if you're working in hertz, that's what's going to do. Now, we know some of our systems, our modular systems, will run in positive negative 5 volts, positive negative 10 volts, depending on what it is that we're doing, what type of hardware or software we're using. So if I turn this all the way up to the top, you can see I go right to 10 volts here. Now you won't hear that. If I turn this up, it's outside human range, so you won't hear it. And if I turn this all the way down, it'll go down to minus 10 volts. And again, if I turn that up, you won't hear it because it's beyond human range. We can't hear that. It's actually 3.9 hertz. Oh, sorry, 0.2555 hertz. So, so we have a range of minus 10 to plus 10. And as you saw earlier, I can go in and I can type that in. Now, let me just tell you a couple little idiosyncrasies of this. If you want to type in your volts here at the top, you can't double-click and type it in. You actually have to go put the cursor in and delete the numbers and put in the voltage you want and hit return, and it will give you that voltage. Or you can click in the window and go Command A or Control A, and once again do the volts. Let's say if you're going to go 0 volts and hit it, and then it will give us 0 volts, which was this note here. Now, which is a little bit cumbersome, but that's all you can do. I mean, this is an open source application, so there may be a few sharp edges. The same thing applies to the other windows for typing things in. Now, if you for calculations as well, if you want to put in A440, which is an A, which we would use for tuning, and you can find out what the volts are for the A in a standard system, which is 0.75. You can also go down here to the lower section and see our note is here. So if you said, okay, I'm in octave 4 A, let's say I want to do a C in that same, and I'm going to tell you another idiosyncrasy. So I'll go 4, C4. C4 hertz is 261. Okay, so another little idiosyncrasy is you can't use small caps. If I did an F, it doesn't make a difference. If I type in a G, it doesn't make a difference until I type in a capitalized G and hit return. Then it gives me my number. So you want to capitalize the letters that you're using in there in this window right here. So be careful of that little idiosyncrasy as well. Not a bug or anything. It's just a little idiosyncrasy. Now, so that's that. And that will again give us the volts at the top and our hertz. Now, down at the bottom here we have cents. Sometimes, let me turn up my volume a little bit. You may, if you were Paganini and you were playing your violin and you were playing with the tuning of A440, and you were Paganini, you might say, okay, well, I'm not going to play A440, I'm going to play A445. And it's a little higher, or maybe A448, and it's a little higher again, so you would tune your instrument to that. So depending on the tuning you want to use, you're going to get a slightly different pitch. So if I'm doing that in the hertz, but if we went down in our bottom into the cents, and we picked A4, and that's 440, and if I said, okay, but I want it to be like 1 cent higher, I can hit that, and that will give me 440.254. You can see in my hertz window. Maybe if we want to go 3 cents higher, it's a little higher. You see that? So that gives us the ability to fine tune things minutely. Let's go, I don't know, say 9 cents higher. There you go. Now we're at 442. So you can fine tune your tuning with the cents here. Now, some of you out there may be saying, look, what's the big deal, Bucky? A few cents here, a few cents there. In the tuning, it's not going to really make that much difference to us. But it really does. And I have some friends of mine who I work with who have microtonal perfect pitch, and they will tell you immediately if you are a few cents out. They can tell. So we want to make sure that everything is exactly the way we want it. And again, I have some friends who do a lot of composition in 432 hertz as an A, and that's minus 31.77 cents lower than our typical A. And that tuning there is something that a lot of people prefer. So just things to keep in mind. You know, it gives us a lot of control over what we're doing. And you can see this down here. You can see what we're doing in the scopes as well. Now, because really the difference between 440 and 442 or 432 is quite small. But if I hit it, a frequency analyzer, look, you can see there is a change. So you might want to use your analyzers to help your understanding of these concepts. Now, I skipped over this 1 per hertz because you know what? I apologize. I have no idea what it is. I spent a half hour with a calculator trying to figure out where that number comes from, and I cannot for the life of me find out what it is. I thought it might have been voltage per hertz or hertz per voltage or some sort of mathematical variation. Can't seem to get my head around what that is. And there's no documentation, so I can't really say. Maybe in the future I may figure out what that is, or somebody may be able to tell me what it is, and then we'll know. But right now I have no idea. Now there is a bug in this software. There's a bug in this module, and this is the octave right here. If I change it with the volume turned down, you'll see here that it's changing. It will change my my readings per octave. So it will change it up here, so you can see my hertz. If I put on, like if I go here and go A440, let's do 440, Command A, 440, enter. And then there it is. If I take my octave and I lower it down, look, see it's lowering down. 220 is 1 octave lower, another octave. So it will do that. But it doesn't affect everything here. It's not changing my volts. It's it also, if I turn my volume up and I change, you see it's not making any difference to my the pitch that's on the output. So I think that it's kind of, I think that may be a bug in the software, so you can be careful of that too. So that's about it. It's a very useful module. Now, as a composer myself of sometimes music that's very dissonant and very without a tonal center, knowing exactly what my frequencies are is critical for the work that I do. So this can be a very useful tool. I really enjoy this one, I have to say. So you may as well. Now, I would love to hear some of your music you make using this module, this utility module. So be sure to link me to it. Send me a link in the comments of this post. If you have any questions, I'll try to answer them as well. And if you have any questions or things that you'd like covered, let me know in either the comments here, or you can get me in the utopian.io Discord, which is, I'll link to it in the post as well. So if you have any questions about that, let me know. I'd be happy to get back to you. Okay, thank you very much, and I will be seeing all of you next time.